Hello everyone, welcome to my channel. In this video, I have 3 algebra questions that I want to work on, just for the love of maths. Now, if you're new to this channel, please don't forget to subscribe. And our first question in this video is to solve for x, and we have 2 to the power x minus 1 is equal to 3 to the power 1 minus x. So, naturally, if the bases are the same, you equate the powers. In this case, bases are different. On the left, we have 2 as our base. On the right, we have 3. So there are 2 approaches I want to take on this. Approach 1, taking us to page 1. Page 1. The first approach to our question 1 is we have 2 power x minus 1 is equal to 3 power 1 minus x. My first approach is to take logs on both sides. So I'm going to say this implies log of 2 to the power x minus 1. The answer should be equal to log of 3 to the power 1 minus x. What you do on one side, you do the same on the other side. At this stage, I'm going to apply what I call the third law of logs, which is log of m to base x. Obviously, the power p is going to be p log base x of m, whatever base you have. Now, if the base of a log is not indicated like this, it must be taken as 10. Right, now look at this form here is what we have there, and therefore it will be this form that leads me to the answer. So I'm going now to apply that law here and say this is the same as x minus 1. Take the x minus 1 to the other side, and then we have log of 2 is equal to, take this one here, 1 minus x, and multiply by log of 3. So that will be 1 minus x times log of 3. Let's expand or remove the bracket. So this is x log 2 minus log 2 on the left hand side. On the right hand side is going to be log 3 minus x log 3. Let's put like terms together. This is going to be x log 2 plus x log 3. On the right hand side, take log 2 to the other side, it will be log 2 plus log 3. Log 3. Because log 3 is positive and we're adding log 2 on both sides. This is what we get. Let's factorize the left hand side. So a common factor is x. We have log 2 plus log 3. And on the right hand side, we have log 2 plus log 3. Now, what is our next step? Our next step, obviously you can guess that our next step is going to be to divide both sides by this expression here. So dividing both sides by log 2 plus log 3, we have x log 2 plus log 3 all over log 2 plus log 3. We do the same on the right hand side. On the right hand side, we have log 2 plus log 3 all over log 2 plus log 3. And obviously you can see that the right hand side, this cancels that. Our answer is 1. And obviously that cancels that. So what do we have as our final solution? X is equal to 1 as our final solution. That's approach 1. Right, I want to show you the second approach. The second approach would be for the same question. Remember, this is the question we have. And I want to look at the second approach. The second approach would be, so let's say option 2. Option 2. And if you allow me to call this option 1. Option 1 using logs. Option 2, simple algebra, we have 2 power x minus 1 is equal to 3 power 1 minus x. Let's dismantle the expressions. The left hand side we have 2 power x times 2 power minus 1. The right hand side we have 3 power 1 times 3 power minus x. And rewriting this is 2 power x times 1 over 2 using the understanding of the negative exponent. On the right hand side we have 3 times 1 over 3 power x, multiply both sides by 2 times 3 power x. What you're going to get is the following. You're going to get 2 times 3 power x times 2 power x times 1 over 2. The left hand side, remember I said you multiply by that both sides. So here we're going to have 3 times 1 over 3 power x times 2 times 3 power x. Now you see that the 2 cancels that one there and the 3 power x cancels that. So on the left I have 3 power x times 2 power x is equal to 3 times 2. Now when laws of exponents, remember we say the following. We say that when you have a b power n, the answer is a power n, b power n. And so when you have this form, you can easily get back to that form. And this is what we see here. So the left-hand side becomes 3 times 2 all power x. And on the right-hand side, what we have? 3 times 2 is 6. So this is 6 power x is equal to 6. And we know that this is 6 power 1. So bases are the same. We can equate powers. And therefore, x will be equal to 1. So the two approaches are giving us exactly the same solution. Right. So that's question 1. Solving for x there. Let's look at question number 2 that I have. Question number 2 is over here. And on question number 2, I'm basically solving an inequality. There it is. That's question number 2. We're supposed to solve for x here. Now, how do I go about this? Well, factorization would be the approach. So number 2, we have x cubed minus x is greater than 0. And I have to factorize. You can see the common factor on the left-hand side is actually x. So we are saying this implies x, open brackets, we have x squared minus 1 greater than 0. Factorizing this part again, we have x difference of 2 squares, remember, x plus 1 and then x minus 1. This is greater than 0. At this stage, when you're dealing with inequalities, you work out what we call critical values. Critical values are obtained by equating each of these terms to 0. So x equals 0 is our first critical value. The second one is x plus 1 is equal to 0. Solving there, we get x equals minus 1. Our third critical value is obtained from x minus 1 equals 0, and it gives us x equals 1. At this stage, I'm going to use what we call the sign table. So sign table, not famous in high school, but this is very critical. You will see shortly. So the sign table basically says we're going to take our x, our three factors. The next one is x plus 1. The next one is x minus 1. And we're talking about the product now, x plus 1 times x minus 1, like that. And we create a table as follows, like that. And then we're talking about basically that the critical values are here. These are my first critical value. There is my second critical value. And there's my third critical value, written in ascending order. My smallest value is minus 1. Then I have 0, 1. Remember, this is the x-axis. That's the x-axis basically. Or you can put it up there, it doesn't matter. Let's pick a value of x to the left-hand side of minus 1. That would be minus 2. If you put minus 2 here, it is minus. Remember, this is a sign table. We're not putting numbers in the table. We're putting signs only. Put minus 2 here, it's going to be minus 1. So we put minus. Put minus 2 here to be minus. Multiply these out. The answer is negative. Let me put it here. It will be negative. That's our product. If you like, we can actually move here like this. Include that part there. I'm just going to do this. Right. Now, and my circles that I've drawn there are all open circles because the inquiry sign is a strict one there. Right. Let's pick a number to the right between minus 1 and 0. Let's say minus half. If you put minus half here, the answer is going to be minus. Minus half here, it will be positive, and here minus half, it will be minus. Multiply these terms out, you get a plus sign. Right. Let's pick a number between 0 and 1. That will be half. If you put half here, it's going to be positive. Half there, it's going to be positive. And if you put half here, is going to be negative, and the product of all these numbers negative. Now if you pick a number to the right hand side of 1, that will be 2. Put 2 here, there, and there, you get positive all through, and therefore the product of all these positive, 3 positive numbers is going to be positive. What are we interested in? We are interested in a positive product. Remember, the product must be positive. And so our solution lies in there and to the right hand side of that. So we can simply say, therefore, x is less than 0 but greater than -1, or x must be bigger than 1. X is greater than 1. So that is our solution coming from the sign table. Very useful tool. With this, you can solve any inequality that you have. All right, let me move on to question number 3, the last one in this short video. Number 3, like I said, this is just simple algebra we're looking at. Here we go. Number 3, determine integral values of x which satisfy the following inequality. So we're looking for whole number values, negative or positive whole numbers. Remember, integers have negative or positive whole numbers, including 0, that satisfy this inequality. All right, so how do we solve this? Well, the first step is to remember there's something dividing now. So we have to work out what is known as the implicit restriction. So number 3, our solution is set out as follows: 2 all over x minus 1. This is greater than or equal to 1. And then we have to work out what is known as the implicit restriction. And it's based on the fact that we are not allowed to divide by 0. So x minus 1 should not be equal to 0. And what does this mean? This means x must not be equal to 1. So that's an implicit restriction. Now, here's another step now. When you have an unknown in the denominator, you don't know whether it's going to be positive. In other words, the whole of this expression, x minus 1, will be positive or negative. And now, in order to prevent that from being negative so that we maintain this inequality sign here, we have to square this one and multiply throughout by the square of the denominator. So we're now going to say x minus 1, we square this, times 2 all over x minus 1 in brackets, and we say this is greater than 1 or multiply by x minus 1 all squared. Now this cancels 1. So on the left now you have 2x minus 1. On the right you have, expand that, it will be x squared minus 2x plus 1. On the left hand side you're going to get 2x minus 2, and we're saying greater than or equal to x squared minus 2x plus 1. Writing this in standard form, we take the 3 terms to the left. We are going to have minus x squared. This will add there, so it will be plus 4x. This will be subtracting minus 2 minus 1 is minus 3, and we are saying greater than or equal to 0. Multiply the whole inequality by minus 1, so we make sure that the coefficient of x squared is positive. Remember, when you multiply by a negative number or divide by a negative number, the inequality sign must change. What am I saying? I'm saying that we all agree that 7 is greater than minus 1. But if I multiply by minus 1 throughout, I'm going to get minus 7. Surely I cannot say it's greater than 1. I will have to say it's less than positive 1. And because of that, the bigger becomes smaller when you multiply by a negative number, and the smaller becomes bigger. So the inquiry sign has to change. So here we're saying x squared minus 4x plus 3. The inquiry sign now changes direction. Factorizing this, if you've watched my videos on factorization, I've explained how you do this. This is x minus 1, and then we have x minus 3, and this is less than or equal to 0. We have to work out critical values. I number the pages, but let's just carry on. Critical values, if I move this one down, working out critical values, we're basically saying that critical values, we are saying x minus 1 equals 0, that part. The other part, the other critical value is going to come from x minus 3 equals 0. This gives you x equals 1, and that gives you x equals 3. Again, going to the sign table, what are we saying? We're saying x minus 1, and then x plus 1, minus 3, sorry. Remember x minus 1, x minus 3. And we're moving on to the product of that. So our next step is going to be the product, which is x minus 1 and then x minus 3. And if you allow me to draw the table here, it will look as follows. And our first critical value is that one there. Then our second critical value is that one there. Now the inquiry sign here is an inclusive one. So the circles must be shaded. However, I shade only this one at 3. The one at 1 cannot be shaded because of the implicit restriction. So this circle remains open there because I can't include 1. Right. Now notice that if you pick a number to the left-hand side of 1, let's say 0. If you put 0 here, it will be negative. Put 0 here to be negative. Negative times negative, positive. Pick a number between the two, let's say 2. If you put 2 here, it's going to be positive. If you put 2 there, it's going to be negative. The product is negative. Pick a number to the right hand side. Remember, this is our x-axis. Pick a number to the right hand side of 3, 4. Put 4 here and there. It's going to be positive, positive, and the product is positive. What are we interested in? We're interested in a product of 0 or less than 0. So our solution is x is less than or equal to 3, but it must be greater strictly than 1. What does this mean? On the real number line, it means that if you have 1 here and 3 there, you have an open circle, and then at 3 you have a closed circle. The question is asking us to determine integral values of x that satisfy this inequality. So there's an integer in between the two of them, and that's 2. So the two integral values that satisfy this inequality are 2 and 3. 1 does not. So therefore our solution is x is equal to 2 or 3. That's our final solution. Right, so this is where I'm going to stop in this short video. I hope you've enjoyed this little work on algebra. We cannot exhaust algebra basically. And like I said at the beginning, if you're new to this channel, please don't forget to subscribe. Your comments are greatly valued. All right, God bless you next time.